Hello children, so let's continue with matrices part 4 today. Now I've taken some more questions here. Let's see. Question number 1. This question came in ICSE 2001. Okay. Now we are given -3, 2, 0, -5 into column matrix x2 is equal to -5 and this y. Now matrix equation is given, so we have to find the values of unknown quantities x and y. Okay, so equal to sign is already used, so we write imply sign here. Now multiply these two. So when you multiply row into column, okay, so -3 into x minus 3x plus 2 into 2, it is 4. Only one column, so it's finished. Now multiply this column by second row here. 0 into x is 0. Okay, plus -5 into 2 is -10. Equal to -5 and 1. Okay. Now, since two matrices are equal, by equality of matrices, their corresponding elements must be equal. So therefore, -3x plus 4 must be equal to -5. First element of this must be equal to first element of this one. Okay, so only x is there, so we can solve it and find the value of x. So -3x equal to -5 and 4 goes there, -4. Okay, this implies -3x equal to -9. This implies x equal to minus, we can cancel, 3 will divide. So 9 by 3, that is 3. Okay, so therefore also we have here 0 plus -10 is -10. So -10 equal to y. So therefore y equal to -10. So x equal to we have 3 and y equal to -10. So these are the values of x and y. Okay. Now let's take question number 2. Now question number 2 came in the year 2005 in ICSE 2005. Here we have to find x if a square equal to b, where two matrices are given a and b. Given a is equal to 2, 12, 0, 1 and b is equal to 4, x, 0, 1. Okay, a and b are given, and also given the relation a square is equal to b. Okay, now we have to find the value of unknown quantity x, which is in matrix B here. So this implies, now put the values of a and b, matrices for a and b. So a is 2, 12, 0, 1. Square is there, so we write once again 2, 12, 0, 1. A square means a into a. Okay, so equal to b is 4, x, 0, 1. Now let's multiply these two. Row into column. So 2 into 2, 4 plus 12 into 0 is 0. Now second column, 2 into 12, 24 plus 12 into 1 is 12. Now second row, 0 into 2 is 0 plus 1 into 0 is also 0. 0 into 12 is 0 plus 1 into 1 is 1. So this is what we get by multiplying two matrices. RHS write as it is, 4, x, 0, 1. Now simplify in the left hand side. 4 plus 0 is 4. 12 plus 24 plus 12 is 36. 0 and it is 1 equal to 4, x, 0, 1. You see, first element 4 equal to 4, 0 equal to 0, 1 equal to 1. So 36 equal to x. So from equality of matrices we get x equal to 36. That is the answer. Okay. Now let's take question number 3. This came in the year 2000. 15. 2015. Now here also we are given matrix A and B. So given matrix A and B. So here A is 3x 0 1 and B is 9 16 0 minus y. So find the value of x in A square equal to B. Once again the same relation given, A square equal to B. So only the elements we have to change here. Okay. So now let's see A square. So A is 3x 0 1 3x 0 1. B is 9 16 0 minus y. Now once again multiply these two. So 3 3s are 9 plus x into 0 is 0. So 3 into x is 3x plus x into 1 is x. Okay, so 0 into 3 is 0, 1 into 0 is 0, 0 into x is 0 plus 1 into 1 is 1. So 9, 16, 0 minus 1. So simplify here, 9 plus 0 is 9, 3x plus x is 4x, 0 plus 0, 1. So 9, 16, 0 minus 1. Okay, so here what we get 9 9 0 0 equal, so 4x must be equal to 16. So therefore we can make, whenever two matrices are equal, their corresponding elements are equal, so that gives you 4x equal to 16, which will give you x equal to 16 by 4. So that is, so therefore x equal to 4. So also we have 1 equal to minus y. This implies y equal to minus 1, multiplying by minus sign both sides. Okay, 4 and minus 1 are the answers. Now let's take this was question number 3. Okay, now we'll take question number 4. Question number 4 came in 2014. Okay, 2014. Question number 4. Now we are given minus 2, 0, 3, 1 and minus 1, 2x plus 3 minus 2, 1 is equal to 2y 3. We have to find the values of x and y. Okay, so we simplify in the left hand side and also in the RHS. So here multiply, minus 2 into minus 1 is 2 plus 0 into 2x is 0. Then second row, 3 into minus 1 is minus 3 plus 1 into 2x is 2x. Is what we get. Plus 3 will multiply, 3 2s are minus 6, 3 1s are 3 equal to 2y and 2 3s are 6. This will multiply both 2y 6. So this will give you here 2 and minus 3 plus 2x. These are unlike terms you can add. Here minus 6, 3, 2y and 6. Okay, so here you can add it. So you get 2 plus minus 6. Okay, and here minus 3 plus 2x plus 3 is equal to 2y 6. So here you get 2 minus 6 will give you minus 4 and 3 3 cancel. So you get 2x equal to 2y and 6. So using quadratic matrices, you get minus 4 equal to 2y and 2x equal to 6 you get. Okay, so this will give you y equal to minus 4 by 2 because 2 will come down here, and that will give you minus 2 2 goes 2 times. Here x equal to 6 by 2 will go 3 times. So this implies x equal to 3. So therefore finally you get x equal to 3, y equal to -2. These are answers. Okay. Now let's take question number 5. Came in 2012, question number 5. So we are given 2, 1 minus 3, 4 into x is equal to 7 and 6 column matrix. Now we have to find order of x. Okay, first the second part, find the matrix x. So number 1. Now you know the rule. Suppose A has element order m by n and B has order n by p, then AB will have order m by, okay. So number of columns must be equal to number of rows, and this will take number of columns from here and number of rows from here. So this one here, this has 2 rows and 2 columns, so this is 2, 2, and here it has 2 rows and 1 column, 2 by 1. So this n must be equal to 2 and p must be equal to 1. That means it must be 2, 1. So order of x must be equal to 2 by 1, meaning 2 rows and column. It takes a number of rows from here, number of columns from here. Okay, so it will take here this one we are finding out. So n will be equal to this 2 and p will be equal to this one. So n equal to this 2 and p equal to 1. So 2 by 1. So now part 2. This is the order of x. Now we have to find x. So to find x, we suppose let x be equal to, it has 2 rows and 1 column. So we suppose A, B. It has 2 rows and 1 column. Okay. So therefore now 2, 1 minus 3, 4 into x. X is column matrix AB equal to 7, 6. Now if we can find the value of A and values of A and B, then we have matrix X. Alright, so multiply now. 2 into A is 2A plus 1 into B is B, minus 3A plus 4 into B is 4B, equal to 7, 6. So by equality of matrices we get 2 equations. 2A plus B is equal to 7, equation number 1, and minus 3A plus 4B is equal to 6, equation number 2. Now we can solve these 2 equations simultaneously and find the values of A and B, and we find the value of matrix X. We find the matrix X, right? Elements of matrix X, that is. So here we multiply equation 1 by 3 and this by 2 to make coefficients equal. Okay, so 6A plus 3B equal to 21. So minus 6A plus 8B equal to 12. So since signs are opposite, so we can cancel here. 8 plus 3, it is 11B equal to, this is 33. So this implies B equal to 33 by 11. So that is 3. So this implies B is equal to 3. Okay. Now we put the value in equation 1 and find the value of A. So from equation 1. Equation 1 is this one. So 2A plus B is 3 equal to 7. So 2A plus B, we put the value 3 equal to 7. So this implies 2A is equal to 7 minus 3. 3 goes to the other side, changing the sign. So this implies A equal to 7 minus 3 is 4 by 2. So 2 times. So therefore A is equal to 2 and B is equal to 3 are the values of A and B. Actually we have to find matrix X. So we write therefore X is, has elements. A is 2 and this is 3. So this is required matrix X. Right? Now let's take another example. That is question number 6. Similar to this one. So 4, 1 into matrix X equal to minus 4, 8, minus 1. Okay. So here we have to find matrix X. Order is not asked, but still we need to know the order to suppose this matrix X. So this has order 2 rows and 1 column. 2 by 1 it is 2 by 2. So number of columns must be equal to number of rows. So number of column it has 1, so it must be 1, and number of columns must be equal to this one, so it will be 2. So you see, number of columns equal to number of rows here, and number of columns here equal to number of columns here. That is the form. So X, order of X is 1 by 2, so that is 1 row and 2 columns it has. Okay, so we suppose let X equal to 1 row and 2 columns. So it is 1 row and 2 columns. Okay, so therefore now we have 4, 1 into X is, we have A, B is equal to minus 4, 8, minus 1, 2. This implies multiply 4 into A, 4. Okay, so only one element here, 4 into B. 4 into A it is 4A, and 4 into B it is 4B. 1 into A is A, 1 into B is B. Okay, so this is equal to, we have minus 4, 8, minus 1, 2. So therefore now by equality of matrices, 4A is equal to minus 4. Okay, and A equal to minus 1. This gives you A equal to minus 4 by 4, that is minus 1, and A equal to minus 1 here. So therefore A equal to minus 1. Okay, so also we have 4B equal to 8 and B equal to 2. This implies B equal to 8 by 4, that is 2, and B equal to 2. So therefore B equal to 2. So A equal to minus 1, B equal to 2. So therefore matrix, required matrix X has elements. It is a row matrix AB. So A is minus 1 and B is 2. So this is required matrix X. Now let's take question number 7, last question for the day. Now number 7. Now given A has elements 3, minus 4, minus 1 and 2. Okay, so we have to find B such that BA is equal to I2. I2 is identity matrix of order 2. Now since A has order 2 by 2 and identity matrix also 2 by 2, so B also should have order 2 by 2 only. Okay, so let B is equal to, we suppose A, B, C, D, meaning 2 by 2. This is 2 by 2. Okay, because A is 2 by 2, this is also 2 by 2, so B also should be 2 by 2. Now, therefore, BA equal to I2 implies B is A, B, C, D into A is 3 minus 4 minus 1, 2 is equal to I2 means 1, 0, 0, 1. I2 means identity matrix of order 2. So let's multiply here. A into 3, 3A minus B into 1 is B. Second column, minus 4A plus 2B, 2 into B. Now by second row, 3C minus D, 3C to D, then minus 4C, then you get plus 2D equal to 1, 0, 0, 1. Okay, so therefore now we get 4 equations here. 3A minus B is equal to 1, equation 1, minus 4A plus 2B is equal to 0, equation number Okay, now here 3c minus d equal to 0, equation 1, and minus 4c plus 2d equal to 1, equation number. Okay, so we can take common here 2 and cancel it out, or we can multiply. So but take common, divide third by 2 here, second equation. Okay, so we get 3a minus b equal to 1, equation 1. This is 1 2, so here we take 3 and 4. Okay, so here it is not required. So divide equation 2 by 2, so you get minus 2a plus b equal to 0. So you can cancel here. If you divide by 2 throughout, so it will go 2 times here, 2 will cancel, 0. If you divide by 2, you get 0. So plus b minus b cancel, so you get a equal to 1 here. Okay, so put the value in equation 1. So from 1, so 3 into 1, because a is 1, minus b is equal to 1, implies minus b equal to 1 minus 3. This implies minus b equal to minus 2, cancel, so this implies b is equal to 2. So therefore a is equal to 1, b equal to 2 you get. Okay, from here do the same thing, 3c minus d equal to 0 as it is. Here take 2 common, so divide third by 2, so you get minus 2c, and here plus d equal to 1 by 2 you get. Okay, so here if you cancel it, d cancel, you get 3c minus c is 3c minus 2c is c, equal to, it is half. Okay, c equal to half. So if you put the value and in equation 4, okay, so because c is half, so you can put the value here in equation 4, so it to get cancelled here. So therefore from 4, equation 4, minus 4 into half plus 2d equal to 1, implies 2 will cancel here 2, so minus 2 goes, that become plus, so 2d equal to 1 plus 2, because minus 2 become plus 2 here. This implies d equal to 3 by 2. So finally a equal to 1, b equal to 2, c equal to half, and d equal to 3 by 2. So therefore required matrix B will have elements A, element 1, and B is element 2, and C is 1 by 2, and D is 3 by 2. So this is the required matrix. Okay.